Good morning, students. In the last lecture, we are discussing with velocity and displacement. Fact number 1 and 2. In this, we discuss with acceleration. Fact number 3. Then, for this, we have velocity time graph. This is velocity time graph for a body moving with uniform velocity and having some initial velocity u. Okay. Now the initial velocity is u and final velocity is v, and the change in velocity is represented by bc, that is equal to v minus u. Okay, and the time taken for this is equal to t. Okay, now as you know that acceleration is equal to change in velocity upon time taken. Okay, so from the graph, change in velocity is bc and time taken is ac. Okay, from this perpendicular upon base, but as you know that perpendicular upon base equal to slope, as we have discussed earlier, then we get acceleration equal to slope of vt graph. Okay, this is the fact third. Okay, now we have three facts. With the help of these facts, we can draw the equation, we can derive the equation of motion by graphical method. Okay, so first equation of motion, as we know that first equation of motion is v is equal to u plus at. Okay, for this we have acceleration is equal to slope of vt graph. Fact number third. Okay, from that we have bc upon ac, but the value of bc from graph is v minus u and the value of ac is t. Then we get a is equal to v minus u upon t. Finally, v minus u is equal to at, and then we get v is equal to u plus at. This is the first equation of motion. This is also known as relation between velocity and time. Okay. Now the second equation of motion. For second equation of motion, we have the same graph. We have the same graph. All the equation we can draw with the help of this graph. Okay. Now, as we know that the fact number 2, displacement is equal to area under Vt graph. Area under Vt graph. Here Vt graph is there. Vt graph, and the area under this is in the form of trapezium OABD. So area under VT graph means area of trapezium OABD. Once again, OABD. Okay, then as you know that area of trapezium is half sum of parallel sides into height. Okay, from the graph, the parallel sides are OA and BD. OA plus BD into height is represented by AC. Okay, the value of OA is u, the value of BD is v, and the value of AC is t. Okay, then From first equation of motion, v is equal to u plus at. So put the value of v. Then we get s is equal to 1 upon 2 u plus at into t. Then we get 2u, s is equal to 1 upon 2 2u plus at into t. Then we get 1 upon 2 2ut in plus at square. Okay. Finally, s is equal to this 1 upon 2 is multiplied in all the bracket. Then we get 2ut upon 2 plus half a t square. Okay. Then we get s is equal to ut plus half a t square. This is the second equation of motion and also known as the relation between displacement and time taken. Okay. Now the third equation of motion. For third equation of motion, we have the same graph and some steps are also same as in second equation of motion. Okay, the steps are, as we know that displacement is equal to area under VT graph, and from second equation of motion, area under VT graph is area of trapezium OABD, but the area of trapezium is half sum of parallel sides into height. Then from graph, as in equation number 2, s is equal to half OA plus BD. OA and BD are the parallel sides and height is AC. The value of these are U and V. OA equal to U and BD equal to V. The value of AC is T. Then these steps are same as in equation number 2. Now from first equation of motion, V minus U is equal to AT. Okay, and T is equal to V minus U upon A. This value we can put this value of T in equation 1. Then we get S is equal to 1 upon 2 U plus V into V minus U upon A. Okay. Then S is equal to 1 upon 2 A V plus U. This can be written as V plus U and we have V minus U. Now from these we have the identity A square minus B square. Then we get V square minus U square. So S is equal to 1 upon 2A V square minus U square. Then V square minus U square is equal to 2A into S. This is the third equation of motion. Okay, and this is also the relation between velocity and displacement. Okay, the third equation of motion has two forms. One is V square minus U square is equal to 2as. This also be written as V square is equal to U square plus 2as. So these are the two forms of third equation of motion. Now the last heading of this chapter is uniform circular motion. Okay, then what is the meaning of uniform circular motion? It means when a body moves on a circular path with constant speed or uniform speed, its motion is uniform circular motion. It means in uniform circular motion the speed is constant. Speed is constant. Okay. As we know that a rectangle has 4 points, a pentagon has 5 points. In the same way, a circle has infinite points. Okay. And at each point the direction changes continuously. So in circular motion, direction of motion changes continuously, because velocity means speed plus direction. So the velocity changes continuously. Once again, in circular motion, direction changes continuously. Now, velocity is speed plus direction. So, velocity changes continuously. Okay. Then, change in velocity is known as acceleration. So, uniform circular motion is an example of accelerated motion. Uniform circular motion is accelerated motion. Okay. Some examples of uniform circular motion are motion of satellites around the earth. It may be artificial or natural. Motion of earth around the sun is also an example of uniform circular motion. Now, in circular motion, total distance is circumference. So, speed is equal to distance upon time. Then distance is equal to circumference. So, speed is equal to circumference upon time. Then we get V equal to 2 pi r, that is circumference upon T. With the help of this formula, we can calculate the speed in circular motion. Okay.